So continuing with equations, all different types of equations. In the last video, we saw equations with radicals within them. Now we have equations with rational exponents. Remember, a rational exponent is just another way of writing a radical. So this is kind of the same type equation. We are still going to isolate the variable expression that has the rational exponent. That's still what we want to do first. So on this first one, we're going to take 25 to the right-hand side. And remember, this means 5 times x raised to the 3 power. So it does make sense in this case to divide both sides by 5. And when we do that, we end up with x to the 3 equals 5. Now, we still are going to use an inverse operation in order to isolate the variable. So right now, this variable x is raised to the 3 power. We need it to be to the first power in order to actually get a solution here. So in order to undo that 3 power, we need an inverse. And that inverse is going to be the 2/3 power. So we end up with x raised to the 3 raised to the 2/3, which if we do that to both sides, the power raised to a power, we multiply those powers together, and of course 3/2 times 2/3 is equal to 6/6, which is equal to 1. So this gives us x to the first power. On the other side, we end up with 5 squared and then the cube root of that. Remember, the denominator of the fractional exponent is the index of the radical. So this is what we end up with for our x. And can we simplify this? No. So our answer is simply the cube root of 25. So that is the first one. Next, x squared minus x minus 4, this quantity raised to the 3/4 power. So same situation, we want to isolate this variable expression that is raised to the rational exponent. To do that, move the 2 over, and we get x squared minus x minus 4 to the 3/4 power equals 6 plus 2, which is 8. And then from there, we're going to use an inverse operation. The inverse operation is going to be using an inverse of this rational exponent. So we are going to raise both sides of this equation to the 4/3 power, because 3/4 times 4/3 equals 1. So these are reciprocal powers, and when we raise a power to a power, they are going to be multiplied. So these two powers are going to undo each other, leaving us with x squared minus x minus 4. On the right-hand side, x to the 4/3 is the same as the cube root of 8 to the 4th. Now remember, we can say the cube root of 8 to the 4th, or we can say the cube root of 8 raised to the 4th. Both of these radical expressions mean exactly the same thing. And we talked before about when to use which one. Well, in this case, it makes more sense to me to look at it first as taking the cube root of 8, because we know the cube root of 8 is 2. If we have to deal with 8 to the 4th, it's going to get a little bit messy, so I don't want to use this one today. So x squared minus x minus 4, the cube root of 8 is 2, and 2 to the 4th is 16. So 8 to the 4/3 is 16. So from here, let's set it equal to 0. Move the 16 over. X squared minus x minus -4 and a -16 will be a -20. And now that we have it set equal to 0, this one's pretty easily factored. What are factors of -20 that add up to -1? X minus 5, x plus 4. So we get two answers here. Remember, set each factor independently equal to 0. So we get x equals 5 and -4. Now, we do need to plug them back in and make sure we don't have an extraneous root. So let's give us a check right over here. So 5. 5 squared is 25 minus 5 minus 4 to the 3/4 minus 2. What do we get? So 25 minus 5 is 20. 20 minus 4 is 16. So we have 16 to the 3/4 minus 2. The fourth root of 16 is 2. And 2 to the third is 8. So we do get 8, and 8 minus 2 is indeed 6. So 5 checks. Let's plug in -4 and see if it is real or extraneous. So got enough room right here. So -4 squared is 16, and then minus -4, so plus 4, minus 4, to the 3/4, minus 2, the 4's cancel. We end up with a very similar situation as the last. 16 to the 3/4 minus 2 is 8 minus 2, and 8 minus 2 is indeed 6. Both of those answers check and are both appropriate. So that is solving equations with rational exponents. We use an inverse power to undo those exponents.